There are currently three main problems with the technologies used by our competitors: small printing size, long printing time, and low resolution. In terms of printing size, Titan 1 can print up to 9.5 inches tall with a 7.54 by 4.25 inch build base at 100 micron XYZ resolution, which is the tallest among all personal SLA printers. For the SLA printers out in the market today, to print a 9.5 inch Eiffel Tower with 100 micron Z resolution, it takes anywhere from 15 to 20 hours. With Titan 1, it only takes about 7 hours. For a 4.7 inch tall Eiffel Tower, it only takes 2 hours. Last, but definitely not least, Titan 1 can print at resolutions that are 5 times better than FDM printers at higher speed. We can print pillar features as fine as a strand of hair. This small Eiffel Tower and the rings are printed at 37 micron XYZ resolution.
Titan 1 is the most flexible and adjustable desktop SLA printer for multiple purposes. Some 3D printers focus on resolution, but are only able to print small objects. On the other hand, other printers can only print larger objects while sacrificing resolution.
Titan 1 is specifically designed for users to easily make adjustments with the widest range printing sizes in the market today. Titan 1 is so flexible that it can print larger objects and can be adjusted to increase resolution and print smaller objects. Speed, resolution, and size can be optimized based on user preferences.
With the Titan 1, you can be a creator for anything. Jewelry for jewelry designers, artwork for artists, models and prototypes for architects and designers, molds, parts, and prototypes for engineers and product designers, design and research models for teachers and students, and many other uses including prototyping and samples for small businesses and niche applications such as hearing aid molds and dental study models. A fun fact about Titan 1 is that you can easily take out the commercial grade HD projector and use it to project HD movies and have your own home theater.
In order to help spread the SLA technology, KUDO 3D further improves on two big problems with the current SLA process: reliability and cost structure. First, to improve the reliability and relax feature maintenance burden, we modularized the components for Titan 1. Titan 1 is simple, elegant, and easy to use. We use high-quality DLP HD 1080p projector and industrial-grade high-precision ball screw linear stage that are used in semiconductor equipment. KUDO 3D's engineering team spent 16 months full-time to develop and perfect the patent-pending passive self-peeling technology to minimize the separation force of cured layers. TSP employs a flexible resin container consisting of 5 different materials to enable a self-peeling process that minimizes the separation force. Therefore, features as tiny as a strand of hair can be preserved during the printing process. Since our PSP technology employed Teflon, our container is immune to the attack of more reactive resin that happens to most of our competitors. Users can use materials from any vendors by setting proper exposure times.
As an artist, I'm always searching for new mediums to experiment with, and recently I've discovered graphic art, but I've been getting frustrated by its two-dimensional limitations, which is why I'm extremely excited about the release of the Titan 1, and to translate the high resolution, quality, the speed of the Titan 1 into my art. I mean, it'll take my creativity to a whole nother dimension.
I'm a civil engineer. I do bridge design. In the recent project that we finished, we have been using 3D technology extensively in our design, detailing, and construction. Within hours, we can print them into physical, tangible objects that we can look at them in detail, turn around, rotate them, look at them in different aspects.
The Titan 1 would be an amazing asset to my studies. In many of my classes, I've been asked to provide sketches of my design ideas for presentations, and I can only imagine my professor's awe when instead of a simple drawing, I can present a 3D concept of my idea. I only wish that this technology had been as affordable and precise in my childhood, because if it had been, my solar system and DNA models would have surely won the science fair.